So next, for the second method of thermal heat transfer, basically we're using convection itself. Now convection, if you notice, the keyword here is the difference in density. So whenever you're trying to explain, describe, or whatsoever about convection, you must mention density. It's a very important keyword, and convection only works in fluids, which means liquids and gases, because they require the movement of particles. Okay, and when we talk about movement of particles itself, more specifically, we're talking about from moving from one place to another place itself. So this indirectly also means that you cannot occur in solids, because solid particles cannot move freely. Okay, so what happens is, typically when you have this, can you see that you can actually chop it up or break it up into different parts. Number one, fluids will first gain heat, become warmer and expand, right? So at the bottom, you can actually omit the other bottom part. You can actually write near the heat source. Near the heat source, near the heater, near whatever that you have. Volume increase, density decrease. Okay, then warmer, denser rise, cooler sink, and then this part here. Okay, so basically you can see you need point number one. First thing, you gain heat, expand. What happens when you expand? You become denser. Then rise and fall. Actually, the number 4 itself, this part here, the cooler fluid, no, all of this is in part. So then basically last part here. Okay, so you can see that there is actually this part. Okay, so if you ever need to, you can just do a quick sketch. So some of you can't the thing is, like me, right, I'm not very good at memorizing words for words. I'm better with illustration, I'm better with equations itself. So what happens is, always remember to play to your strengths. If you know for sure that yes, I'm not very good at memorizing stuff like me, right, then just play to your strengths. I play a lot of video games, so I'm get better when I see graphics, when I see it's moving. So number one, the fluid at the bottom or very near the heat source itself gains heat and expands. Volume increase, density decrease, and what happened? You rise up to the top, and once you reach the top, what happened? You can only move to the sides. So what happened? Does the cold water? The cold water actually will be displaced downwards, and they will actually move to the side. Now, if you notice, I said cold water. That's actually wrong. My bad. It's cooler fluid, because it's actually the same temperature as the rest of the water. It's just that compared to the hotter heated fluid, it is colder. Okay, so what happened? You will see that you actually form this circular shape, right, where it's convection like this. So actually, some schools want you to draw circular. You don't actually have to. You can just draw up, down, right, left, up, left, down, right. Perfectly fine. Now, this is when you're heating up an object, right? What happens if I'm trying to cool down, or this is hot water? What happens when I am cooling down hot water, or I just leave it out? Why does it go cold? Because don't forget, it is the hot air that become less dense and rises, while cold air comes in to replace it. So what happens? You're effectively taking heat away from my hot water. So if that's the case, the last part here, this part here, you need to change the phrasing. So let me tell you how. First thing, when the air near the surface of the hot water gains heat and expands, the volume of heated air increases and becomes less dense. The warmer and less dense air will rise up, while cooler and denser air from the surroundings. So you can see some of the words that you actually just swap out will sink to replace the heated fluid. Okay, so the cycle repeats, forms your convection currents, decreasing the temperature of the hot water quickly and uniformly. So you can see, right, like I said, thermal chapters are very, very application based. First thing you need to identify and ask yourself is, what is my object? If my object is the hot water, is it the hot water gaining or losing heat? If the hot water loses heat, how? How does it lose heat? Where does it lose heat to? Who takes the heat away? You need to ask yourself all of this. Is it the suddenly on top become cold and you need to fall down and then you have a convection current, or is it the other way around? So you need to be very, very careful itself. If you do say that on top becomes cold and you have a cooling convection, why did it become cold? You need to specify. So a lot application, you need to link here and there. So like I said, this chapter, Looks simple, just pure memory work. However, for you to do well for this chapter itself, you need to be very, very familiar with what is going on, how it happens, and actually apply it properly to the question. Because literally your teacher can just look at the aircon. I'm gonna test you on the aircon. He can look at the freezer. Okay, I'm gonna test you on the freezer. So just remember, don't hard memorize just the heating one. This one here is for heating. There's also a cooling one when you can use to explain as well. Okay, so let's take a look at the example below. Now, if I have a coolant pack which is cold, so this fella here is cold, and I place it on top. Why must it be placed on top to cool it down? Because number one, the air near the coolant pack cools down and contracts, becoming denser. The cooler and denser air will sink to the bottom, while warmer and less dense air at the bottom will rise up to replace the cooled air. Okay, then what happens next is, okay, so what happens next is the cycle repeats to cool down the food within the cooler box rapidly and uniformly. Okay, so this is how it works typically. So now don't forget what the question is asking you. Why must it be placed at the top if the coolant pack is not placed on top of the food? The convection currents formed will not reach the top of the food. As a result, the food at the top will not be cooled and may spoil easily. Okay, so basically this is why the cooler pack should be placed on top, because remember, your warmer and less dense air at the bottom will only rise up to replace the cooled air. If you were to place it somewhere lower, where it's like this, right? What happens is you only cool this part. What about this part here? This part not cooled, because the cooling part will only achieve around this area. So on top will still be warm. Can you understand? So that is why you actually need to place your coolant pack usually at the top. So anytime you want to cool something down, you should always be placed it at the top. That's why all your air conditioners are always placed at the top of the room itself, and all your heaters or any kind of heating device will always be placed at the bottom. So if some of you have gone overseas before, you all can actually see that usually the floors are heated rather than the ceiling itself. Okay, so be careful of that.